Okay, so we were given this question. OAB is a triangle where O is the origin. So anytime you have a question like this, you need to draw the triangle. Okay, so let's say this is a triangle. OAB is a triangle where O is the origin. So let's say O is this. This is our O. Let's say A and B. Where O is the origin, P and Q are midpoints. P and Q are midpoints of OE. So OE will have a midpoint of P. And what? OB. So Q. Respectively. The position vectors of OA and OB are A and B respectively. So let's also take their position vector of OA. So from O to A is what? And from O to B is what? Is B. Write down the position vectors of P and Q in terms of A and B. Write down the position vectors of P and Q. So we need to write the position vector of P. The position vector of P. Now we know that P is the same as OP. Is that right? OP. So let's say that to find OP, how do we find OP? But we can join these together. Know that we can join from P to Q together. We can join them together. So to join them together, we can start by saying that if I want to move from O to P, where will I pass? That is the question you have to ask anytime you are dealing with such problems. If I want to move from O to P, where will you pass? I can pass through OQ to where? OQ to where? QP. But when you do that, you don't know QP. Do you know QP? No, you don't know the vector there. Now remember that we know the vector OE. We know the vector OB. Do we even know the vector BE or AB? We don't know them. But there is a relationship between PQ and AB. They are what? Yes, they are parallel. Anytime you write the midpoint of P and Q, the midpoint of OE and OB, wherever they intersect, becomes parallel to AB. So let's take note of that. These two lines are parallel. So now, if the question is asking us to express what? Write down the position vectors of P and Q in terms of A and B. Now you ask yourself that, how do we write P? P is just the midpoint of AB. So I can just write that OP. If I want to move from O to P, it is the same as moving half of what? Half of what? Half of OA. Are we okay? Good. And if I want to move from A to B, it is just the same as moving half of what? OB. But if I do it that way too, it means that I have just written OP in terms of only A, and I have written OB in terms of only B. But the question is asking us to write them or express them in terms of A and B. So where will you pass to get there? I can also say that OP, I can pass through B, pass through A, and pass through this. Are we okay? So now we have to look for a way where we can move. We can move from O to where? We can move from O to P. But we are not going to pass through OP straightforward, but we are going to pass through different routes to get to P. So as you said, we can move from O to B. Then we move from Q to where? Q to P to get to OP. But the challenge is the QP. The QP, we don't know the vector there. So what do we do to get that vector? Let me look whether I have represented everything. Okay, so it means that there's no way, because since they have not given you any ratio here, there's no way you can express AB in terms of A and B. So the way the question put it is a bit confusing, but it doesn't really mean that OP must be expressed in terms of A and B at the same time. What it means is that express OP in terms of A and B. It means that it can be expressed in terms of A, it can be expressed in terms of B. And also expressing OQ, that is Q, in terms of A and B means it can be expressed in terms of A or in terms of B. So here we can just go ahead and find OP. We know that OP is equal to half of what? O what? Then what is the unit vector of OA? Is what? Is A. So we have OP should be equal to half A. But remember that OP is the same as P. OP is the same as P. So P is equal to half A. Then you do the same thing for this. So OQ should be equal to half. OQ should be equal to half what? OB. Half OB, which is the same as OQ should be equal to half of OB is also what? B. So Q should be equal to half B. And that's all. That's all. Now let's go to the B. Now P, negative 1, 1, and Q, 1, 3, and R, M, N, and S, 3, negative 1, R. So this is a different question. Let me use. Alright, so P, negative 1, 1, Q, 1, 3, and R, M, N are vertices of a parallelogram. So here what you have to do is to draw a parallelogram. Is that right? So okay. So we have P to be negative 1, 1. We have Q. Now pay attention how I am writing the coordinates. We don't write the coordinate PQ and RS. We don't do it like that. PQ, RS. Anytime you name it like that, everything will be wrong. We always name it either clockwise or anti-clockwise. I believe under coordinate geometry, I said that. So PQ, Q is 1, 3. And R is MN and S is 3, -3. Okay. So that is the parallelogram. PQRS. Calculate the values of M and N. We are to calculate the values of M and N. So how do we find M and N? How do we find the values of M and N? Yes, tell me. Now you can go this way. Now, if this is a parallelogram, then it means that this side is parallel to this side. Is that right? So it means that these two vectors are the same. These two vectors are the same. It means that PS, vector PS, must be the same as vector what? QR. So let's find vector PS. Vector PS is the same as OS minus what? OP. Is that right? And that should be equal to vector QR, which is equal to OR minus OQ. Are you following? Okay. But we need to express, these are points, so we need to express them in terms of coordinates. These are points, we need to express them in terms of vectors. Is that right? So let's start with the first one, PS. We can find PS. Let's find PS. Okay. Let's first find OS. Now OS is the same as S, but we need to write it in terms of vector. So it's going to be 3, -3. Then let's write OP. OP is the same as P, but we need to write it in terms of vector -1, 1. Please, you have to do this part because they will mark it. Then we need to find OR. OR must also be written in terms of vector, which is M, N. Then finally, OQ. OQ must be written in terms of a vector, which is 1, 3. Now we can do the substitution. So we know that okay, so there's no need to bring the PS. Remember that we said PS is equal to QR, is that right? But PS is the same as OS minus OP. So let's just do the substitution. Our OS is what? 3, -3 minus OP. OP is what? -1, 1. Then should be equal to OR. OR is what? MN. Then minus OP. OQ. OQ is what? 1, 3. Good. So from here, can we do some change of subject? First of all, let's subtract the 3 minus -1 is what? -1 minus 1 is what? Minus what? Minus 4. Now this is -1, 3. Let's bring it here to be plus 1 . Then that will be equal to what? MN. So here we have 4 plus 1 is what? So MN should be equal to 5 and what? -1. Therefore, our M is what? And our N is what? Good. That is all. Is it difficult? Now, what are some of the properties of a parallelogram? One property is that the diagonals bisect each other. The diagonals bisect each other. Is that right? So if the diagonals bisect each other, then it means that this point is supposed to be the midpoint. It's supposed to be what? The midpoint. So I can say that the midpoint is given as, we can find the midpoint using S and Q. Is that right? Let's use S and Q to find the midpoint. 3 plus 1 is what? Divided by 2. 2. Negative 3 plus 3 is what? Divided by 2. So the midpoint here is 0. If the midpoint here is 0, then it means that because they are all the midpoint, it is the midpoint of S and Q, and it is also the midpoint of P and what? R. Is that right? Therefore, we can also find MN if the midpoint of PR is 2, 0. Are we okay? So we are going to say that the midpoint, it means that 2, 0 should be equal to the midpoint, which is negative 1 plus M divided by what? Then 1 plus N divided by what? Divided by 2. Are we okay? Good. So let's solve this one. The first one is going to be 2 should be equal to negative 1 plus M divided by 2. And we have 4 should be equal to negative 1 plus M. And M is equal to what? 5. Then we can also solve the second one, which is 0 is equal to 1 plus N all over 2. Then we have 1 plus N is equal to 0. And N is equal to negative 1. Is that right? Which of the approaches do you like? First or second? I use coordinate geometry for the second. I use vectors for the first one. Remember that it is a WASSCE question. So they will not tell you use vector approach. Use this. So you can use any of the methods. You can even use thousands of methods. So whichever method you use and you get the answer is correct. Can we move on? Now solve this one fast. Given that P this, can you solve this one? Solve this one. The first person to solve will take 1 CD. Given that P is 3, 5, Q is 2, negative 1, and R is equal to 5, 17. Express R in terms of P and Q. Please, when is your first paper? This year? 20th. 20th. Oh, you have more months. Or you have less than a month. 2 weeks. So by 2 months' time, everybody will leave the square, or some of you will be here. By 60 days to come, some will still be in school. Are you done? Yes. Find, given that P is equal to 3, 5, Q is equal to 2, negative 1, and R is equal to 5, 17. Express R in terms of P and Q. express R in terms of P and Q. If we are expressing R in terms of P and Q, then we can say that R will be equal to some scalar multiplying P plus another scalar multiplying Q. Is that right? Where alpha and beta are scalars. So it means that R is going to be equal to alpha multiplying what? 3, 5. Then plus beta multiplying 2, -1. R has been given, is that right? So R is what? 517. Good. So we have 517 should be equal to 3 alpha, 5 alpha, then plus 2 beta, negative beta. Alright. So here we can say that 3 alpha plus 2 beta should be equal to 5. And 5 alpha minus beta should be equal to what? 17. Equation 1, equation 2. You can solve for alpha and beta. Solve for alpha and beta for me. What is alpha? Alpha is what? And beta is what? Minus what? Okay, so once you have gotten this. Now, remember the question says we should express R in terms of P and Q. So this implies that R is equal to alpha, which is what? 3P. Then beta is what? Minus 2Q. And that is the final answer. So we have expressed R in terms of P and Q. That's very simple. Is that right? Good. Okay, so express PR as a column vector. Can you solve this? Now we know PQ, we know PQ, and we know RQ. Is that right? The question says we should find PR. But we know that PR is the same as what? PQ plus what? Plus Q R. Or we can say that PR should be equal to PQ, because we have PQ there. Then minus what? So QR is the same as negative R hot Q. So you have this. Then you do the substitution. So PR should be equal to PQ is A, B minus RQ, which is C hot, CD. And we have PR to be equal to A minus C, B minus what? D. Alright. Can we move on? Good. We are done. Show that this are vertices of parallelogram. You can do this. This is similar to the first one we solved. Is that right? Good. So once you draw the parallelogram like this, let's see something like this, you can use either this side and this. These two sides, you equate this side to this. Is that right? Or you can also equate this to this because they are all the same. Then once the left-hand side is equal to the right-hand side, because this one you are showing something. So once the left-hand side is equal to the right-hand side, then it shows that it is what? A parallelogram. Are we okay? Good. A, B, C, D is a parallelogram. Show that A, B is equal to is such that A, B is this, A, C is this. Find B, C, B, D, the unit vector in the direction of B, C. Start with. Find A, B, C, and B, D. Then we do the C together. Everybody solve it fast. What's BC? Now BC is the same as, remember we have AB and what? AC. So BC is the same as BA plus what? AC. But we know that BA can also be written as negative what? Negative AB then plus AC. Are we okay? So let's write negative AB. Negative AB is going to be negative. Remember we have 3I plus J. So it's going to be negative 3I plus J. Then plus AC. And AC is what? 5I minus what? 3J. Now we can expand this one to be negative 3I minus J plus 5I minus 3J. Now let's add corresponding components. So we have negative 3I plus 5J will give us what? Then negative J minus 3J is what? And that is the final answer for BC. So BC is 2I minus 4J. Let's do the same thing for BD. Now we know that BD is equal to, we have C there, so BD can be BA plus, do we have D there? Okay, so alright, so let me draw the parallelogram and use it to analyze the BD. So we have we have A, B, C, and D. AB is 3I plus J. So that is a vector. AB is 3I plus J. Then we have AC. Okay, so AC is what? Five I minus 3J. So we have to find BC. So we have done the BC, is that right? But we know that BC is the same as this and this. Good. We are done with the BC. Now the next question is to find BD. Now BD is going to be the other diagonal, is that right? So this. So we are finding BD. So now the question is, how do we find this BD? If I want to move from B to D, I can move along BC, BE, then I'll also move from A to D. Is that right? So here, we have to know that AD, so you see, if you don't draw it, you will not be able to identify it. We know that AD is parallel to what? And they have the same length. Therefore, AD, vector AD is the same as vector what? BC. So AD is the same as BC. So now we can find the BD. We know that BD is given as BA. This is BD, right? So BD is the same as DE plus what? Plus A what? A. BD is BA. BA plus what? AD. Is that right? Good. But do we know BA? Did we solve for BA? Okay, we know AB. Right. So we can say that BA is the same as negative AB. Then plus AD. But we know that AD is the same as what? BC. So plus BC. Are we okay? Then you now substitute the values into it. So we are going to get BD to be equal to negative AB. Negative AB. Where is AB? 3I minus what? 3I plus what? G. Then plus BC. Where is our BC? 2I minus 4G. Then we can expand. So we will have negative 3I plus 2J, which is negative I. Then J, negative J minus 4J is negative 5J. Is that the answer? So we have BD to be equal to negative I minus 5J. So most of vectors question and even coordinate geometry, if you don't sketch the diagram, you'll not be able to solve it. You need to sketch to know the relationships. Alright. Can we move on? Now today, after class, 8 o'clock exactly, I have a class with some students. We are still doing coordinate geometry 1. We shall be looking at perpendicular lines, bisectors and those things. You can join the class. It is an online class. You can join it if only you have your phones and if only where you stay to watch is also secured. Good. You can enjoy it. You don't have to be here. Wherever I'll be to teach, you can still enjoy. I'll put the link on your WhatsApp platform. But you need to download Google Meet, the app. Is that right? And you can join to learn. Anytime I have a class, I'll put the link there. So you can join and make good use of your phones. At least you can learn with it. For those I will be teaching, some of them are in AIS. Others are in Precept. But they are informed 2. You are informed 3. So when you come there, show to them that you are informed 3. Now let's move on to this question. Wasi Novdek 2007. A 3-1, B -19, and C 1-2 are the vertices of the triangle ABC. E is the point on AB such that the magnitude AE, the magnitude of vector AE is equal to 1/3 the magnitude of vector EB. Find AB, AC, and CE. Can you solve this? Okay. So the first thing to do, so ABC are vertices of the triangle ABC. Okay. So we have A, 3, 1. We have B, AB, B is negative 1, 9, and C is 1, negative 2. They are the vertices of the triangle ABC. E is the point on AB. E is a point on AB, such that, so we are going to use this to locate the position of E on AB. So now we see that we have AE is equal to 1/3 GB. Is that right? So from here, let's divide both sides by EB. You will get AE over EB should be equal to what? 1 over what? Therefore, we can say that AE is to EB is equal to 1 is to what? Therefore, from A to E is in the ratio 1, and from E to B is in the ratio 3. Therefore, we can see that E is closer to which? A or B? E. So it means that I can divide here into, let's locate the point here as E. Then from A to E has a ratio of 1, and from E to B has a ratio of what? That's all. Will you be able to do this analysis? Simple. Alright. So now from here, what do? The question says we should do what? Find AB. We should find AB from A to B. Now before that, AB is very simple. We know that AB is equal to OB minus what? OA. But always you need to define OB. We know that OB is equal to what? OB is the same as the point B, but it has to be written in terms of what? A vector as negative 1, 9. Then our OE must also be written in terms of what? Vector, that is A, 3, 1. So we have AB to be equal to OB is negative 1, 9 minus OE is what? 3, 1. And that will give us negative 4 and what? 8. So we are done with AB. Now let's go to AC. We can also do the same thing for AC. Is that right? So you know what to do. Before you find AC, you have to find OC. And OC is the same as what? 1, negative 2. So now we can find AC to be equal to OC minus what? OA, which is 1, negative 2 minus OE, which is what? 3, 1. And we have negative 2 and negative what? Okay. So now let me write it here. We know that AB is, what did we get for AB? Negative 4 is right. And we have AC. AC is negative 2, negative 3. And the question says we should find C. So CE is from C to E. We are finding C. Okay, so we still have to apply the midpoint, this time the ratio formula, is that right? To find C. Now take note that always this is a unit vector, goes with this. Then this side must also go with what? Must also go with. So let me just write this one here. This must also go with this. That's the rule. Good. So we are going to find C. That's from C to E. So we can say that CE is giving us. We are using the midpoint, the ratio formula. So CE should be equal to what? This vector multiplying 3. Is that right? So we are going to get 3 multiplied by what? Negative 2, negative 3. Then plus what? Plus this vector 1 multiplying BC, then all divided by the sum of the ratios, which is 3 plus 1. So now we need to also look for BC. Is that right? Which we can do that. BC, we can find BC. So let's start. We can also find C. Are we okay? So what is C? Okay, we don't know C. Is that right? So C should be equal to 3 times negative 2 is what? Then 3 times negative 3 is what? 9. Then plus 1 times BC. So let's find BC. BC simply means C minus what? OC minus what? OB. So we have CE to be equal to negative 6, negative 9, plus OC is what? 1 what? 1 negative 2, then minus OB. OB is what? Negative 1, 9. Okay, so we have CE to be equal to, here we just add. Negative 6 plus 1 is what? Plus 1 is what? Is what? Negative 4. Then negative 9 minus 2 is what? Negative 11 minus, is it 9? Minus 9 is what? Negative 20. And that is our C. So our C is negative 4, negative. What about what? Wait, 3 plus 1. Wait, 3 plus 1. Is it not negative 4, negative 20? The question says we should find C, isn't it? From C to E is negative 4, negative 20. Huh? We have not divided. Okay, 3 plus 1 is what? So all over 4, is that right? Good. So when you cancel out, you have CE is equal to negative what? And negative what? 5. Good. And that's the final answer. You are a great mathematician, okay? Okay. Alright, so that is it. Any question on that? Any question? No question. So let me ask another question. B. Find the coordinate of E. Find the coordinate of E. Can you find the coordinate of E? Yes, you should be able to find the coordinate of E. Now we have CE to be negative 1, 5. Is that right? So if CE is equal to negative 1, 5, then you can find E. Because you know that CE should be equal to E minus C. Is that right? And that is negative 1, 5. Negative 1, negative 5. And we know CE to be what? 1, negative 2. But we don't know E. So you can find E. Are we okay? Do you understand the analysis I'm doing? Simple. Even if you don't know CE and they tell you to find E, you should be able to solve using coordinate geometry. Remember that this part, only this line is a line. Is that right? And it has been divided. The E has been divided in the ratio 1:3. So you can find the division, the point of division given the ratio 1:1, 1:3 using coordinate geometry formula. Are we okay? Do you understand? What is mx2 plus nx1? Is that right? All over m plus n. We have done all these things under coordinate geometry. Hey. Morefi. Under coordinate geometry, if you have a line, let's say A, x1, y1, B, let's say x2, y2, and you divide a line in the ratio m:n. I use lambda, is that right? And mu. So m:n, then we are saying that the point of division xy, the point of division xy is given as mx2 plus nx1 all over m plus n, comma, my1 plus, my2 plus ny1 all over m plus n. Do you remember this? Simple. That's how to find the coordinates of the midpoint. And not the midpoint, but the point of division. Okay, but remember this is an internal division, is that right? Whenever you have the external division, you negate the smaller ratio. Do you remember all those things? Simple. Good. Okay. But even this question, we didn't finish. You didn't tell me the C part, or you can solve the C part. We didn't finish with this one. We were able to find BC and BD, is that right? But the C was to find the unit vector in the direction of BC. The unit vector in the direction of what? BC. How do we find unit vector? Unit vector. Now, the unit vector of any vector is given as, the unit vector is given as v hat. Is given as what? V hat is given as the vector itself over the magnitude of the vector. This is the formula. Unit vector is equal to vector over magnitude. Unit vector is equal to vector over magnitude. A unit vector is a vector whose magnitude is a unit. A unit vector is a vector whose magnitude is a unit. What is a unit? Whose magnitude is what? Is 1. Any vector which has the magnitude to be 1 is termed as a unit vector. Is termed as what? Example is I. I is a unit vector. Now, how do we write I in a component form? A column form will be what? 1 what? Let's find the magnitude of this. 1 squared plus 0 squared, square root. The answer is what? Another unit vector is G, which is 0 what? 1. Is that right? Which is going to be 0 squared plus what? 1 squared. The answer is what? So they are all unit vectors. So I is a unit vector along the x-axis, and J is what? A unit vector along the y-axis. Another unit vector is I sine theta plus J cos theta. This is a unit vector. Let's find the magnitude of this. Square root of sine theta is what? So we have sine square theta plus cos square theta. Sine square theta plus cos square theta is what? Is what? 1. And square root of 1 is what? So it is a unit vector. Are we okay? We are done with unit vector. All right, so let's learn more about unit vectors. Now, we can see that AB and PQ are parallel. Is that right? Vector AB is parallel to vector PQ. If two vectors are parallel, let's write. Then they have the same unit vector. If two vectors are parallel, it doesn't mean that the vectors are the same. Are we okay? Because two vectors can be parallel, the same direction, but their magnitudes are different. Are we okay? Magnitudes are different. But if two vectors are parallel, they have the same unit vector. They have the same what? So let's take note of that. What it means is that I can give you this vector to be, let's say, vector AB is, let's say, 1, 2. Are you following? Then I can tell you to find vector PQ. Let's say the magnitude of PQ is 5 units. What is happening here? I have given you the magnitude of PQ. Is that right? But I have not given you the vector itself. But I have rather given you a vector of AB, where AB is parallel to what? PQ. Then I'll ask you to find the vector PQ. So to find the vector PQ, what do? Now you know that if two vectors are parallel, it means that the unit vector of AB, must be the same as what? The unit vector of what? So all what I need to do is to use the AB, find the unit vector of AB, and that will give me AB hat. That's the unit vector of AB. And because they are parallel vectors, it means that the unit vector of PQ is still AB hat. Is that right? Then I can now find the vector itself. But remember that the vector PQ is given as the unit vector, or the vector itself. We are finding vector. So now we are going to use this formula that unit vector is equal to what? Vector over what? Magnitude. Is that right? By this time, the question is rather asking us to find the vector. So the vector is going to be equal to what? The unit vector times what? The magnitude. Is that right? So now, remember that to find the vector PQ, the magnitude has been given. We know the magnitude to be what? 5. So all what we are going to look for is its unit vector. Is that right? But we can only find the unit vector by finding the unit vector of AB. Because they are all parallel, the unit vector of PQ is the same as the unit vector of what? AB. So once we get the unit vector of AB, we now put it here to be AB hat. And we will get the vector PQ. Are we okay? Are we okay? Simple. Alright. So now let's go back to the question and solve. Are you writing? Okay. So the question was this. We didn't finish with this one, so we are coming back to this to solve the C. So now solve the C. The unit vector in the direction of BC. The unit vector in the direction of BC. So here what do? We want to find the unit vector in the direction of BC. Where is BC? BC is this. And what is the vector there? BC is what? Our BC is 2i. 2i minus what? 4j. And the question says we should find the unit vector in the direction of BC. So all what we are looking for is we are looking for the unit vector of BC. Is that right? So it's another way to say that find the unit vector of BC, or find the unit vector of any vector parallel to BC. And we know that parallel lines have the same unit vectors. So you find the unit vector of this. To find the unit vector U hat is equal to the vector itself over its magnitude. Is that right? So what is the vector here? The vector is 2i minus what? 4j over the magnitude of this. And the magnitude is root of 2 squared plus negative 4 squared. So we have 2i minus 4j all over 2 squared is 4. 4 squared is 16. 16 plus 4 is what? 20. Root of 20 is what? Is what? 2 root what? 2 root 5. Are we okay? Then the 2 cancel 2 and cancel 4. So we have I minus j minus 2j all over what? Root of 5. And that is the answer. Are we okay? Please, those who don't understand, raise up your hands. Okay. Remember, hey, what is the time? Say so. We have not even started the dot product. Too. We are still on vector 1. Okay, let's look at this. Let's solve this one. Try this question. The coordinates of points P, Q, and R are 3, 1, negative 3, 4, 1, 2, respectively. Find A, 3PQ plus 2QR. Can you do that part? Good. So all what you need to do is to express each of the coordinates in terms of vector. So we have OP to be equal to 3, 1. Then we have OQ to be equal to negative 3, 4. Then we have OR to be equal to what? 1, 2. Yes. So once you are done with this, now the next thing is we find PQ. Is that right? Let's find PQ. PQ should be equal to what? OQ minus what? OP. So we have PQ to be equal to OQ is what? Negative 3, 4 minus OP is what? 3, 1. And what is the answer? Negative C is what? No. Okay, this is equal to. And what? 3. Okay. Then we have, the next thing is to find QR. Let's find QR. QR is OQ minus OR. Is that right? So QR should be equal to OQ is what? Negative 3, 4 minus OR is what? 1 what? 1, 2. So QR should be equal to negative 3 minus 1 is negative 4. Then we have what? 2. Good. So now we can do the substitution as 3 what? PQ is what? Negative 6 what? Then plus 2. QR is what? Negative 4 what? Good. And the final answer is what? Negative 18, 9. What? QR is what? Minus what? Are you sure? So the answer will be 4, negative 2, right? Good. So it will be negative 2. Let's write. No time. You can correct it. Right. So it will be negative 4, negative 2. Negative 4, 2. 4, negative 2. Okay. So we are going to get plus 8 and what? Negative 4. And the final answer is what? Negative 10 what? 5. And that's it. Now the question says B, the unit vector in the direction of PR. So all what you need to do is to find the vector PR. Do we know PR? Let's find PR. PR is equal to what? OP, OR minus what? OP. And OR is what? 1, 2 minus 3 what? Good. And the answer is what? Minus 2 what? 1. So now we know our PR. PR is negative 2 1. Are we okay? Good. Now the question says we should find the unit vector in the direction of this vector. So all what we need to do is that unit vector, always remember the formula, unit vector, which is PR hat, is equal to the vector itself, which is PR, over its magnitude. Is that right? So the vector is -2, 1, divided by the magnitude, and the magnitude is going to be -2 squared plus what? 1 squared. Is that right? So the final answer is going to be, let's work the magnitude first. -3 squared is what? 9. Is it 2 or 3? -2 squared is what? Plus 1. Root of 5. So we have 1 over root of 5 into bracket -2, 1. Is that right? You can leave your answer here, or you can write it as -5, -2, -2 root 5. Hey, is it -2 root 5? No. It's going to be, let me even rationalize it. So it's going to be 5 what? Root 5 on what? Multiplying -2, 1. Is that right? Good. So you can expand. When you expand, you are going to get -2 root 5 on what? 5. And we have root 5 on what? 5 as the vector. So that's the unit vector. If you find its magnitude right now, you get 1. You can try. So that's it. Okay. We have solved a similar question like this. Is that right? So you can solve it. Write down, solve this. Write down the following vectors in the form AI plus BJ, where A and B are scalars. Then M, so I is M is equal to, so here it means that the vectors have been given in which form? Magnitude bearing form. Is that right? And we are to express all in the Cartesian form. That's what the question is asking us to do. We did that yesterday, so I'm giving you 1 minute to do it. So it's very simple. We have 4n and 180 degrees. Remember that to write it in the Cartesian form is going to be 4 sine 180 I plus 4 cos 180 J. Are we okay? Now let's write 4 sine 180 is what? 4 sine 180 is what? Is what? 0 I plus 4 cos 180 is what? Negative what? Negative 4J. So the final answer is negative 4J. Are we okay? Did you get it? Good. Then do this one. Now, in fact, what I'm writing here is the same thing. Remember, I give you the formula R sine theta, R cos theta. This is in a column form, but to write it in the Cartesian form, it will be IR sine theta plus what? IR cos theta. And that's what I am using here. J R cos theta. That's what I'm using. So it's the same thing. So write the second one. So those who are confused, you can first write it in a component form. Like this. So for example, this one I can write it as 10 sine 150. Then 10 cos 150. Are we okay? Let's write 10 sine 150 is what? 10 sine 150. 5. And 10 cos 150 is what? Minus what? 8. Hey, I can't hear you. Negative 8.67. Okay. Alright. So we have, then after that you write it in this form. So it's going to be 5I minus 866J. Are we okay? And that's the final answer. Now the question says, use your result in 5A to find 2m plus 3n. Remember that the first solution was for m, and this is for n. Is that right? So 2m plus 3n, you should be able to do that. It's going to be 2 times negative 4g, then plus 3 times what? 5I minus 866g, and 8.66g. You can simplify. Is that right? We are done. Can we move on? Am I moving fast? Are you sure? Okay, so what is the time? Time. 6 what? 25. Okay. Now, if I project, just glance through and tell me if you can solve, then I can move on. Can we solve this one? We have done the ratios. I believe you can solve this one. Okay. The position vectors of points P and Q are this respectively. If the unit vector in the direction is this, find the values of K. Solve this. Solve this one. Okay. The position vectors of points P and Q are P I minus 7j and Q is 4I plus kj respectively, where k is a constant if the unit vector in the direction of PQ. So first of all, you need to find PQ. Is that right? So now we can say that PQ is equal to Q minus what? Q minus what? Because their position vectors has been given. So we have PQ to be equal to Q is I Q is what? 4I plus kg. Then minus P. P is what? I minus what? 7G. So we have PQ to be equal to 4I plus kg minus I plus 7G. So we have PQ to be equal to 4I minus I is what? Then kg plus 7G is what? K plus what? 7. All what? G. Are we okay? That's all. So we have 3I plus K plus 7G. That's it. Good. If the unit vector in the direction of PQ is this. So now they've given us the unit vector. The unit vector of PQ has been given as 0.6I plus 0.8G. But we can also find the unit vector from here. Are we okay? That is, unit vector of PQ can be given as 1 over the magnitude of this vector, which is 3 squared plus what? Plus K plus 7 what? Squared, all square roots. And this is equal to multiplying, or let me just write it this way. The vector is what? What's the vector of PQ? 3I plus K plus 7G. Okay. So this is the unit vector. But remember that the unit vector has been given, so we need to equate the two. So we have 3I plus K plus 7G all over. Let's solve this part. We have root of 3 squared is what? Plus what? K squared plus 14K plus 49. Is that right? And this is the same as 0.6I plus 0.8G. So we need to simplify and equate corresponding components. Is it going to be tedious? You want? Okay, so we have 3I plus K plus 7G all over this. So let's simplify. We have what? 3I plus. Okay, so let's K plus 7G all divided by 49 plus 9 is what? 50 what? Plus the 14 is what? 9 plus 14 plus 49 is what? Is what? What are you saying? 9 plus 14 plus 49. This one is 14K. Oh. Okay, so we have K squared plus what? 14K. 9 plus 49 is what? 58. Okay. All should be equal to 0.6I plus 0.8J. The square root. Okay, so how do we eliminate the square root? That's the problem. Let me check something. Now solve the quadratic equation for me. K squared plus 14k plus 58. Now solve this one for me. Check this one for me. 14 squared minus 4 times 58. What's the answer? 14 squared minus 4 times 58 is what? Check that one for me. What did you get? What you give students, they will not do. 14 squared minus 4 times 58 is what? Negative 36. Oh, then it's not a perfect square. I was thinking it's a perfect square so that we can simplify. Let me check something. Okay. No, let me go back to the question and analyze it well. Now check the PQ for me. Is it correct? The PQ is still correct, eh? Okay. I'm coming. Okay, so I'm still analyzing the question. All right. So please, we will close soon. Let's rework it because the equation I'm getting is becoming very tedious to solve. Let's take it again. Let's take it again. All right. The position vectors of the points P and Q are, so we know point P to be I minus 7J. And we know Q to be equal to 4I plus Kg, respectively, where K is a constant. If the unit vector in the direction of PQ is this, so first of all, what we need to do is to find vector PQ. We need to find vector PQ. And we know that vector PQ is Q minus P. So PQ is given as Q, which is 4I plus Kg. Then minus P. P is I minus 7G. So we have PQ to be equal to 4I plus Kg minus I, then plus 7G. So we have PQ to be equal to 4I minus I is what? 3I. Then we have Kg plus what? 7G. Okay, which is the same as PQ should be equal to 3I plus K plus 7 or G. So we have gotten back the same thing. Okay. Alright, let me look at it again. Okay, so what you do is that let's try and find the magnitude. Let's find the magnitude of PQ. Let's find the magnitude of PQ, which is PQ should be equal to the square root of okay. Let's find PQ. Please, let's find PQ squared. PQ squared will give us We are multiplying the two, is that right? Or let's first find the PQ. The PQ is going to be, that's the magnitude. The magnitude will give us 3 what? Square root of 3 squared plus k plus 7 all what? Squared. Okay. So we are going to get the magnitude of PQ to be equal to 3 squared is what? Is 9 plus this will give us k squared plus 14 k plus what? 49. So we have PQ should be equal to the root of so there will be a problem of square root of k squared plus 14k plus what? 50 what? Okay. Alright, so we have gotten the magnitude of PQ to be this. Okay, so it means that our unit vector in the direction of PQ, that is going to PQ hat, is going to be the unit vector, that's the vector itself. The vector of PQ is what? Is this, which is 3I plus K plus 7J, all divided by the root of k squared plus 14k plus 58. And this unit vector is the same as what has been given, which is 0.6i plus 0.8j. Now, how to solve this equation is the problem. So it is your assignment, okay? Don't go, we are not done. This part is your assignment. Yes.
When you get to this side, you split this and you see 3 over the denominator, then this one 2 over the denominator. Then when you get this one, the whole of this one becomes I, and the whole of this one becomes D. Then you equate the corresponding result. You get that? You see, it becomes 3 over roots of k squared plus 14k plus 58. Then k plus 7. Then when you equate it to this one, and you equate this one to this one.
You have gotten the answer. I think the answer is correct. Okay, so Madam Afrakoma says, what's your other name? Madam Brafra. Has suggested something which may work. So now you know that if you have, let's say, A over B, A plus B all over, let's say, C, it is the same as A over C plus B over C. Is that right? So we are applying that concept to split it. So it means that we can write this vector. Now we have gotten the unit vector, which is the same as, we can write it as 3 over root of Let me even check something. Okay, so k squared plus 14k plus what? 58. All I, is that right? Then plus k plus 7 over the same thing, which is root of k squared plus 14k plus 58, all g. And this should be equal to what? 0.6i plus 0.8g. Are we okay? So since we have divided them into components, we can equate. So we can equate this one to this. Then we also equate this one to what? This. Is that right? Okay, so we are going to get 3 over k squared plus 14k root of this plus 58. Then we equate this one to 0.6. Is that right? Okay, so from here we will get, or we can, let me square both sides straightforward, to get 3 over 3 squared over k squared plus 14k plus 58. Then should be equal to, I'll also square here. What do you get? 0.36. Okay, then we can multiply through. So we are going to get 0.36 multiplying k squared plus 14k plus 58. Then it should be equal to 9. Are we okay? Now divide 9 divided by 0.36 is what? Check for me. Is it 25? It's 25. So we have k squared plus 14k plus 58 should be equal to 25. So we have k squared plus 14k plus 58 minus 25 equal to 0. And we have k squared plus 14k plus 58 minus 25 is what? Is what? 30. 33. Okay. Then you can solve this one. Is that right? What is k? K is equal to what? Negative 3 and what? Negative 11. Well, so you can also use the other one to solve, but you should get the same thing for k. Is that right? Alright, so clap for Madam Afrakoma. Hey, clap for her. Now, all those who need help, you go to her, okay? Who wants her as a friend? Wife. Okay. Audrey, watch demo. Okay. Are you writing? So we are done with vectors 1. Can we start vectors 2? If I should start now, we will end in 3 hours time. So, no, right now, 8 o'clock, I have a class online. That's why I said you can join, if only you can join. Let me share the link on your page for you.